All right, yeah, welcome back to the second edition of this course. We last the first one we did, we tried to introduce ourselves to this environment called data science. We try to understand what data science is and the other component of data science. We look at the career in data science and introduction to R. And to install R, you have to install R first. You download here. If you're using Windows, if you're using Mac, you have to Google for the Mac version. So you download from here and install. After installation, then you go to R Studio. R Studio is installed by posit.co. Right, when you Google from when you Google, you'll find it will open here. So you just need to scroll down a little bit, go to the open source edition and click on download RStudio desktop. So when you download, then you install. So when both is RStudio, we automatically select R by default. So you don't need to connect together. By default, it automatically select R that you have installed. So if all the versions of R you have installed on your computer will be seen and loaded by RStudio. So you can swap, you can change from one version to another version from RStudio preferences. So that is how we begin our training today. Now let's go ahead now and look at the RStudio environment. Okay, so we have the first I want to explain is this particular panel that's in here called source code panel, or otherwise called script editor. This is called script editor or source code panel. So whichever two of them is correct. All right. So this place is where you write your script and edit your script. All right. Now, formerly, before RStudio came to stay, we have this type of we have console before. In console, that's where you type your code, right? And you run your code at the same time. You type at the same time, you run at the same time, but it's not editable, all right? You cannot edit the code you have already typed, and you cannot just keep like that. So you have to, when you type the code, it's already forgone. So you have to write again, or to run again afresh. So, but with RStudio or with this script called script editor, you can write script and run as many times as possible and edit as many times as possible. All right. So that is this environment called how script editor. All right. So this is where you type your major code. Okay. You can actually type the same code here, like I said before, in console and run. Okay. But it is more easier when you type from here. This place also is very interactive, just to type and run once. But here you can just type and save. Now, for you to open this, just click on File, New Script. You click on New Script, our script here to come, or you can just open here. Open here, our script here. So if you are not new to R, you can skip this step actually. All right. But if you are new to our environment, I think it's better you listen to this. So we also have another environment called environment here. Environment here, you can see it's empty because nothing has been run yet. Any program I'm running here, it will reveal my objects that I'm working with here. So all the objects I'm working with here, if I create a variable, the variable will show here. Anything I'm doing here will be reflecting here. All right. For example, now if I create a variable, now if I run, it will show you that, oh, this object I'm working with at the moment. It will list all the objects which I can access also from here. All right, so it's called R environment. So we have history, that what you have done so far in this, so it will be listed here, all the work you have done so far. Okay, so we also have connections and tutorials for R, where you can get tutorials on R. Now, if you go down to this panel, you have plots. The first thing you notice here is plot, always automatically enabled by itself, because when you are plotting, you are running a code here that has to do with graphics or plots or charts to show here in this plot. So that's where it will draw the plot here for you. You can save, you can export, you can copy from here. So make your plot very visible. So you can adjust here. You can see I can adjust to make the short plot bigger. All right, I just make it smaller so to explain. All right, so also this one can be adjusted up and down. All right, you can see adjust. All right, so if you can reposition this particular one to where you want to put this one here, put this one here, you can drag them around. All right, yes, you're allowed to drag them around, you can reposition them. If parametric, this one is not showing, you're not showing it, just come to here, open it again and open it, so I run it, so to show again. All right, so these are the major elements, and you have packages here, package, which automatically all the package that you have installed so far will be loaded here. You'll be seeing all of them here. Some packages are default, are loaded by default. They are called system packages. They are loaded by default. You don't need to load them. So I will show you how to load packages. So you have to load libraries before you can use them. But all this you are seeing here, they are already installed library on your system, whereby whenever you want to use it, you have to load them. All right. But there are some that are already loaded by default. Even though you don't need to call them. Those ones are marked. They are checked already. When you see anyone checked already, it means you don't need to load them, already loaded by default. You can use them directly in your code. All right. For example, when you see, let me see, try to locate those ones are loaded by. For example, you can look at this base library is loaded by default. So you're going to call base. Okay. We have a dataset is loaded by default. Graphics, GR device. We have methods. Okay. We have stats. They are loaded by. We have utilities. They are loaded by default. So you don't need to load them, but others that are not loaded by default, and if I want to use them, you have to call them. So these are the installed library on my system. So we have app area that where you can load help. If you want to have help, right? Look for help somewhere. Maybe you are trying to look for help. Maybe help on a maybe I want to get help on. Let me just look for a topic. Maybe compute. Compute have different area actually. So there are many compute in different library. So let me look for something like a paste. Let me say I want to say paste, and now so I just type paste. I want to find help on paste. So to show on help tab here in this panel, so I can learn more about help. Okay, about paste. Okay, this paste is under a base package, or under a base library rather. So you can see that it's already giving me a lot of help. What I need to know about this package, this particular syntax, this function called paste that I typed just now. It's a function, so I give you more details about it and how to use it. Okay, so this is how to this is called R environment. So I'm just doing that in console. I could have done that also here, all right? But I just do that here. So if I want to clear this one now, I can just press Control L, clear the space, all right? All right. So if I want to run my program, I just click on run from here. Okay, run the current. So anyone I can click here to run. I can drag over them and select them and run together. Click on run. Okay, so that is how to work in this environment. All right. So now, okay, we have a file tabs also, which that shows your normal system files that you have on your files you have in your C drive and even on your document file. So just display them here. So that is not necessary for now. So that is just a R studio environment. All right. So I have many more to learn, many things to learn here. As you join the gradually, you see many things to learn from here. But what is very important, I want you to notice also is your what you call session, otherwise called working directory. Working directory is very, very important in R, because if you are working with R, you must create a working directory. Working directory is a directory or a folder where all your files are stored and will be stored. Okay, it means that any file you'll be working with, images, data sets, and the rest of them, you must have a folder where they come from. So R is interested in your working directory. You can simply type working directory here. For example, if I say get working directory for me, get working directory, this is code to get that. If I press enter to show me that this is my working directory. Okay, documents, right? So this is my working directory presently, but I will change that later. All right, I can change it from here. All right, just click on session, go to set working directory, go to source file. For that source file location, which you have, I've already opened now. This file I already opened now. I can set it to that. I can set my, I've opened the file just now. This file I opened. It has a location. on my system. So I can set it to that location, all right, to that folder, or I can choose any directory for myself, okay, and set it to my working directory. So that's where all my files are saved, all right. All my files are saved in that place. So if I run an image, I want to save image, I don't need to be browsing where to save my image. Automatically save there. If I want to save a data set, I want to save anything I want to save, everything will be stored on my working directory automatically. So that is how to work with working directory. All right, so let's go gradually. By now, I believe you must have installed your R and RStudio. All right. Okay, so if you have not done that, you can go ahead and do that. So, and you have understood the R environments. So let's go ahead and discuss a little bit about R syntax. In R environment, we have a R syntax. All right, so how we interact with R code. Every language or programming language has a syntax, the code. Basically, we can do some arithmetic in R by just adding and subtracting like a normal calculator. So here we have 2 plus 3, 5 minus 2, 3 times 4, and so on. You can run this, you can just run this, you know, I can drag like this, I just run, you can run. All right, if I run, you can see here it's giving me the result of this. These are just comments, okay, commenting now, okay, just commenting now. Like you're using this hash means comments. So I want to comment, I comment here, so I put hash. For each of one of the one line of code I want to comment, I put hash, then add my comments. So now I have this 5, 3, 12 giving me the answer of this calculator, what I had, what I subtract, what I multiply, and what I divide. So now that is how you add and subtract in R. So now we look at what is called variables in R. R has some variables and data type, and there are rules to variables in R. And where the key name, first thing is called valid characters. What that means that the variables names must consist of letters, numbers, periods, and underscores. So however, they must start with a letter or a period followed by a letter. All right, so you cannot just type anything in R called variable. You must follow the rules of variable, else you'll be having errors in your code while it runs. So because R is very case sensitive, R is case sensitive means that a variable name must be consistent and accurate when you are using them. If I type variable, for example, my variable here, they are not the same. Because this one is typed for a small letter, then combined with a V uppercase. This one signed with uppercase, combined with V uppercase. This one signed with small letter and small letter together. So you can see that they are not the same. Even though they look alike, they are not the same. Why? Because the letter I'm using, they are different, uppercase, lowercase. So they are considered different variable in R. So you must understand that the variables in R are case sensitive. All right. Okay. So now we have what they call reserved words. Some words are otherwise called keywords. Keywords are reserved words in R. Those are the code languages that R uses. So you cannot use them in variable names. All right. You have to avoid using reserved words or function names in R as variable. They include keywords like if, else, for, function. They are built-in function named like sum, mean, and so on. You cannot use them as variable name because they are already inbuilt function in R. R will give you error. For example, I just use paste now, paste. Okay, I just use paste. Paste is a function. I cannot use paste as my variable name. Okay, if I want to use paste, I have to add something to it. All right. If I want to use any one of these, I have to have something to it. Maybe on paste underscore my variable or underscore something. So that is how I can say some underscore variable or anything I want to add to it. I must match it with something else so that will make it different from reserved words. We also have length. Variable name can be of any length, but it's not good practice to keep them concise and descriptive for readability's sake. You know, you can have a lot of a longer length variable, you can type a long length, but it's not advisable to do that because you need to make something that you can easily remember and type very easily. All right, you cannot just write a sentence as a variable combined together. It doesn't make any sense. All right, so and it must be descriptive means that it must something that you have to remember easily and that makes sense with what you are doing. If I want to sum two variables together, I can type maybe and write sum all, for example. That's a variable name for me, sum all. You see now, so it makes sense. Now I know that I'm summing something together, something like maybe 3 plus 4 or variable 1 plus variable 2. I'm trying to sum together, even though there's no variable 1, variable 2 is defined for now. I can use sum. For example, I type here, I say var1 equals to 2, var2, I'm the variable 2 now, variable 2 equals to 3, for example. Then I can say sum all, okay, sum all equals to, I cannot use sum now, all right? I can only say sum, use inbuilt function, give me the same answer, all right? So, but I say sum all equals to v1 plus v2, v1 plus var2, all right? So now I've done this. I can run this very easily now. Then to run. So for me to see the results, I just have to, I can run this guy only. Either I type this guy here, I can say, okay, I want to view some all right? I can view, or I can just select this guy only this guy. I can run this guy only, give me the results, okay? I can actually use inbuilt function, sum function, var1, comma var2, all right? So to view the sum of what I've just written, all right, so I can run from here, give me the same answer 5. So this is called inbuilt function. This is my own manual addition, okay? All right, so that's just a variable for you to handle variable. So avoid special characters. Why some special characters like a period, underscore are allowed. Period is allowed, underscore is allowed. Even most time, $sign is allowed, but avoided. You can create a variable like a maybe for example some for example dollar whole, for example. It's allowed in arrow. I will not complain. Okay, it's allowed available. So, but avoid it. Okay, avoid the same. I can say var1. Let me just say 3 plus 2, 3 plus 2, 3 plus 4. Okay, error. You can see it gives me error now. Some or object type predictive function. Okay, so now this, you see this as object built-in, or this is already built-in now. Okay, some $or is built-in function because I'm using some $or, which means this particular function exists. It exists. So we'll have used something else. All right, so that is exactly what I'm saying. Avoid them. I can use it with other variables, but it will work. Okay, yes, but this particular one did not work because it is already complete built-in function, because some $or is exists. All right, so we also need you can start your letter with, a letter. Variable name must start with letter, okay, not with number, either upper or lowercase, or a period followed by a letter. They cannot begin with a number. I cannot start a variable with a number. Okay, I cannot say 3 underscore something. No, it must be with a number. No space in variable name. You can't say space. Don't put a space. I cannot say my space variable. Okay, no space between variables. You must either you concatenate, either you combine together using underscore, all right, or you use dot to combine together. I can say var1 dot var2. Okay, I can say my variable, all right, it's correct. Okay, now so 3 plus 4 is correct. All right, I can also say my underscore variable. I can use this one to combine together, right? It's correct. Okay, 3 plus 4 is correct. You can see the way I use equal to assignment operator in R. This is actually R assignment operator. Okay, but this is also allow in R. Okay, R allows it in case you use this way. I will not complain. Okay, so now descriptive words mean that you have to choose a word that are descriptive, that are meaningful. Okay, don't just use any words. You can use it because I'm creating a variable. Maybe I want to count. I can say count all, for example, because I want to count all. We are dealing with data set. You'll be able to understand what I'm talking about. A meaningful name. A meaningful name. I want to create a function. A meaningful function. Maybe some function to sum all. You call it sum all function. Don't just call it any name. Some name that are readable and have understanding to your your code. So you must choose that. All right, let's move forward. So you can see these are valid variable names. We have you can see my variable, my dot variable, my underscore variable, var123, var123 underscore 123 dot abc a dot b dot c. They are valid variable names in R, and these are invalid ones. We have 123 can start with numbers. It's not allowed in R. Can see my space is not allowed. Okay, dash is not allowed. All right, at is not allowed. You can see. So if it's a keyword or reserved word, for is a keyword or reserved word, you can see already giving me errors here. Okay, you can see errors. I say unexpected token variable. You can see give me errors. So you must note all these errors as you work with R. You must note them. All right. So that is exactly. So we have what is called numeric variables, which you are assigned a number to, called numeric variable. Okay, maybe numeric underscore var is equals to 42. That's a number. You can have a character variable, that's one that allows string. This is called string or character. Okay, so you also have a logical variable which takes true or false. That is a logical variable. So we assign and multiply variables in R. For example, a is equals to 5, y equals to 10, z equals to s plus y. Then we run z to see the answer. So if I run this now, I will not see any answer yet. Okay, because I have not yet run my final z, which I assign everything to. So I have to run this separately to see the result of what is in z. All right. Don't forget, I can change this one to equal to like this. It's also accurate. Okay, there's no problem in R. Okay, R can recognize that very easily. All right. So that is if I run C now, of course I should be able to get. I just put my cursor here and click on run here, or I can select this Z and run. So same, give me this. I have the answer here in the console. All right. So we have a comment in our arrow. Uses comments. Anything you put hash in front of it and type is called comments. You can see all my comments here. You can see them. So I commented those ones so that I can to show to the reader what I'm doing. So these are comments. They are not executed in R. All right. So we have R workspace, which I have just explained now, called script editor. This environment, I've just explained that now. We have console, we have just explained now. We have environment and history, which I've explained just now. You can see what you are doing now already showing here in R. You can see our history, our environment. You can see them. So showing us a function, everything we are doing is showing here now. All right. So that is environment. So we have not plotted anything here. That's why this was blank. I plot something to be shown here as well. So we have plot and files. This displays plot and files. So that is where I explained just now. You can also get help from her, which I just give you a sample help to get help from her. This is called general help. Okay, general help. I can just type this code. I'll get it. I can get help from her using this help.start. All right. If I type this help.start now, I can get help easily. All right. You might this dot. I just put it. So okay. So for example, this general help from her. Okay, if I run this one, how to get any general help generally under help. So just tell me more about how. Or if I also want to get a particular function, I can just help. I put the function inside. For example, now help paste. Like the other time, I can put I can run this guy. This function, it will give me help on function. All right. You can see here. I can also do it the way I do it before. I can just put the paste here. Okay. This guy, they're the same. They're both the same. All right. Anyone I prefer I can use from the two. If I run, also give me the same thing. All right. So there's what they call apropos. Apropos means you want to supply, so a list of functions. This list all functions containing string foo. So if I supply string foo here, maybe I'm looking for something. I don't know what exactly, so I can just say apropos. I want to know some kind of a terminology that I don't understand. I want to know more about it. I can type apropos here and just type it. Maybe I can say maybe what is string. I don't know what the string is in her. I can just type apropos string, or concatenate in her. I can run here to give me more details about it. All right. So that is apropos. So that is what it does. So example here. I want a sample of that function, example of string. For example, I can type string example. So I run here to give me one actually in example string. No f found for string. Okay, say no f for string. So never mind, just keep moving. Now R contains packages, or what I call libraries. When you download R, already a number of around 30 packages are already installed minimum. You can see, so those I just showed you on the packages just now. There are many packages already installed on your system, so you can search for them by typing search. You want to know either you go to package and see them, or just type search here. If you give a search, you can give you some. You can look at it here. So whatever you want to search for, you can put inside here. All right. So to attach another package, what do you do now? You can install it first. How do you install packages? Install the packages. You put package name here. Okay. Install the packages. So you put package name. So if I just type install the packages now, I type the package I want to install here in the code. I've already installed base, so I don't need base anymore. All right. So it's already installed by default. Anyway, there are many more packages you'll be using as we proceed. Okay. For example, tidywise. Go to tidyverse. Rather, we're going to be using it later. So many packages are going to be installed later. So, but to run the package, to call it, you have to load it by calling library and put package name inside here to load the package automatically. All right. So when you click on this and you run, let's say I want to load mass package. I have to click on run. Mass package will be loaded, and see it's showing me that it's loaded here now. If any error, to show me if there any warning, maybe the package is not meant for that particular version of R, it will tell you here that it's not meant for this R version, but it can still work. All right. So don't be confused or dismayed by the warning messages. They are warning, they are not error. All right. So that is normal in R. So R uses a lot of functions, inbuilt functions. For example, length. To know the length of object, okay, you use length in R. All right. We also have string object. Okay, I want to know the length of particular object. For example, if I create an object, I've created some object here already. If you check, I created object Z, and it's an object. This I've not run this one now. I've not run this. Maybe I run this guy, like this character var. If you can't hear 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a nice including space. Okay, space is part of it. So that's a length. If I now want to, I can say length. I can find the length of this. I can say length. I put in bracket my variable name. I want to know the length. So if I run this, it will give me the length of this variable. Okay, it's giving me 1. Give me 1 as a length. All right. So because it's going to show me as a combined one character, 1. So go back here. Let me come back here. Give me length object, the number of elements or components in that particular one, just 1. So we have string. How string means this a structure, that structure of an object. So if I run this now, I put a character here now. Character underscore var. If I run this line now to give me structure of this particular, give me. So I have a string. It's a character variable number 1. Then what I have inside is hello R. Class is giving you the class of the object, the class the object belong to, right? Object or character. If I create a variable or anything I created to, or data set can tell you where does it belong to, which class does it belong to. We have several classes of a object. Okay, some are data frame, some are data frame, some are just normal string object, some character object. So to give you from a list, all right, some are table, depend on the object you are creating. So you can just click a class and it will give you. So if I just put a class here now, for example, for this, I just type class, this object I run from here to give me character here. So that is class it belongs to. Names, me want to name the object names. If I create some functions of variable name, I can just type names here. So what are the names of this because sometimes when you create a data set, it comes with several names. You want to know, for example, I have a data set called student, for example, and it has names. So I can just type what name of variables or column that I have in that data set. So you can list them for me automatically. So we have C object, it means combine object together. Okay, I want to combine, this means concatenate. Okay, combine object 1, object 2 together. So as into a vector. So you see how to use that as we continue just now. How to bind, I mean to bind object 1, object 2 together. Combine object 1 as in form of columns. It's called column bind. We have row bind also, want to bind in form of rows. Okay, we can bind rows together, we can bind columns together. All right, we have list. To list the current object in database, can list them. So that's called arrow list. So we have a arrow remove object or delete object. So it means remove object. If you want to delete an object from the database, maybe you have been using some object repeatedly and you want to clear your space, and just say delete object. You don't want it to exist anymore. Okay, new object means you want to create a new object which should be edited. For example, if you want to create your own data set manually, you can just click on new object equal to edit. This is just a variable. All right, you created yourself, then you are calling this function called edit to supply this object. It means it will go to open to open for you a small window by which you can now edit the object. All right. So viewing data now in R, there are a number of functions for listing the content of or content of a variable in R. Okay, this I don't use class object here, which I just listed now. Okay, now we have a variable called my data to print my data out. Now, if I create object my data, for example, I can print my data. Just enter just select this guy and run it to show me what is inside this particular my data. If I want to print out the only first 5 rows, first 6 rows, I just say head. I remove this head. If I just say head, my data, for example, to give me first 6 rows here. If I want first 10 rows, I just say okay, comma, n equals to 20. I want 20 rows to be displayed from this particular data set to show me 20 rows. All right, this one show me 10 first 10 rows, and this one show me last 5 rows, till last 5 rows. So this is how you print out your data and to display on the screen. So we have our data structure. That structure talking about the structure of data in R. The first step in data analysis is the creation of data set. Okay, first you have to create data set by doing manually. For example, if I want to do manual method now, I just create a vector manually. I can just okay, I can just come here and type A equals to this, B equal to this, C equal to this. All right, the first thing is vector. So you can refer to elements of vector using this numeric variable. So you can just run these guys. So I've created vector A, B, and C. So if I want to see what is in A, I just need to enter A. I see A, B, C. So inside what is inside A, B, and C. One can refer to element of vector by using numeric vector. For example, if I want to refer to any element of this vector now, for example, A, this is 1 by index, right? If I say A equals to this, for example, right? This is my A. So I can refer to my third element, 1, 2, 3. This is number 5. Okay. I say A3, it means 5, the third element, which is 5. All right. If I want to see the fourth element, I put a fourth to give me 3. All right. If I want to say A, C, I want to combine many together. I want to see 1, 2, 3. I run this. Okay. First element, third element, and fifth element. So I use C to combine many index together. All right. Which gives me first, which is 1. Give me the third element, which is 5. And give me the fifth element, which is 6. You can understand that. So, I want to also see it in form of from 2 to 6. Okay, I want to run from 2 to 6 from here down to this place. So this method will be used to handle your variables or columns of your data set very easily. All right. So if I run this now to give me from 2 to 5, so from 2 here to 5 to 6 here. So 1, 2, 3, 4, 5, 6. Okay, from 2 to 6. All right. Okay, 2 here. Okay, we have 1, 2, 3, 4, 5, 6. So 1, 2, from 2 down to 6. 1, 2, 3, 4. So this is 1, this 2. All right. Then to 6 to stop here. All right, so that is what you do. So stop at -2. All right. So also have what you call matrices in R. Matrices deal with rows and column, two-dimensional array, where each element has the same elements, okay, has the same same mode, character, numeric, or logical. So we have a create a variable called my matrix, for example. It has now called a function called matrix function. All right, it has a can pass in vectors, number of rows specified, number of columns specified. All right, so we can now specify more dimensional names, okay, which with the list functions can pass in here. So for example, if I create y equals to my matrix, for example, I call the function my matrix. I want a 1 to 20, okay, this is my vector 1 to 20, and number of rows I have. I want 5 rows, 4 columns. If I run this guy now, for example, to give me already created now y. So I want to see my y. I just type y. You can see this is my y. Okay, it give me I have 1 to 20 as my numbers. As my vectors. Now I now want number of rows, 5 rows, 1, 2, 3, 4, 5, 5 rows. Columns, 4 columns, 1, 2, 3, 4, 4 columns. So that is 5 by 4, okay, row by columns. All right, so that is how you can create any number of rows you want anyway. So that is how you handle matrix. This special passing could be any data frame, could be any other thing to pass in. All right. You have cells. Cells, each of them is a cell 1, cell 2, cell 3. You can cell row wise or column wise. All right. So I can create in this format also by using cell method. My cell is equal to this, or if you just a variable, don't mind this is a variable. Okay. C equals to 1, 2, 3, 4. I have this pass to this one. So I said my row names is what my heading row names is this, my column name is this. I'm just creating this as a variable now. Okay, this is a variable. I say I pass these vectors, these are vectors. Okay, so this is also a vector as column name. And now create my matrix is called a matrix cells. This one, this is my vector. I pass my vector, this vector file say I created here, I pass it here. All right. I say this 4, 1, 2, 3, 4. So row by columns now, 2 rows, 2 columns. All right, that is my matrix now. That is 2 by 2. So and I say, okay, by row it's equal to true. So this is, I can say by columns if I want by column or by row. So I want by row equal to true. Then I can come here, I can say dimensional name list, which we saw as another time. It's equal to list. I want to put our names 1, our names 2, row names and column names. These are my dimensional names. So this one will give me the headings and beside it columns. So if I run this line of course now, for example, if I run this line of course, I run my matrix. What is in my matrix? So give me, you can see the headings here. You can see, give me the rows, the columns. All right, so it's 2 by 2 matrix. We also have a way of a subtracting matrix. Matrix can be subscripted. Okay, if I have my matrix, for example, this, as usual, I create a matrix of 1 to 10, n rows equal to 2, number of rows 2, what it means. So I can just look at my matrix, how it look like. X, what is it? Number of rows 2. I said I want only 2 rows. It give me 1, 2 rows. Even though I have 10 numbers in my vector, I have 1, 2 rows. So I can access the element in the second row. This you can see in matrix is different from in the way we did here. All right. Okay. In vector. All right. So now in matrices, I'm dealing with rows and column right now in matrices. Okay, rows and column. This matrix gives me first row, second column. Right. So this row, this column, this row, this row, this column, this row, this column. So now this is about second row now. This is second row, nothing in the column. So I don't want anything in column, but I want second row only. If I run this guy now to give me the second row, right? Second row, this first row, this second row, all right? So if I run this guy now, give me the second row. Okay, this second row now. Everything in second row. I don't want the column. I want the column only, second column. I don't want the rows, right? If I run this line, give me column, second column, this second column, right? I want to see what is second column. I don't want row. So you can see here, this place is empty, nothing there. This particular place empty for rows. Only columns I want to see. Now I want to see first row, fourth column, first row, fourth column. So I can run this guy. Okay, first row. The first row means this first row, this first row. Okay, first row. I want to subset this first row and second column. All right, so this is a part of intersection now. First row, all right, second column. This is giving me only three. This three. So if I run this line, I should have three. Or okay, I mean fourth column rather, fourth. 1, 2, 3, 4. So 7. That is 7. Sorry for that. So I can also add multiples here. Don't mind this. So I can have -1 here, 4,5. I want this particular column. I want to minus, means I want to eliminate this column 1. I don't want to see from column. Then in the row, give me 4 and 5 elements. Okay. The first element row, I want to subtract this one and give me 4 and 5 only. So I can run this line of code. Oh, sorry. I want to remove. This one supposed to also be there. I'm trying to run this element 1, column 1, then row 1, then I want column 5 and 6. So this is what I run. Okay. All right. So sorry for that. So that's it's an error. So we have a column row 1, column 4 to 5. All right. So try to combine the string together here. So that is how you subset in matrices. Also, you can subset array similar to matrix, but can have more than 2 dimensions. We have a array. I can create array object here, the array function, vector, dimension, and dimension name. So this array help you to know to combine many dimensions together. So I can say dim1, dimensional 1, c equals to a1, a2, dimension 2, dimension 3. So I'm trying to create a different dimension of array. Okay, I can run this line. So z equals to array. I create this function now. All right, this is my vector. Okay, I create another one here, and I'll say dimension 1, 2, and 3. All right, so I'm trying to combine them together now in a array. So if I run this c now to give me this, give me this. Okay, c1, c1. All right, it's equal to, can give me this. Okay, dimension 1, dimension 2, dimension 3. You can see. Okay, see what to give me. This c is the dimension of each of them. Separate them 1, 2, 3, 4. But my dimension 2 is b1, b2, and b3, which is giving me here the headings. Okay, why the this one is actually the column. This one is column names. This one is row names. All right, see row name. This row names. This column name. So, but each of them is breaking down into 4. 1, 2, 3, 4. All right, so that is just how to subset that. Then we have data frame. Data frame generally is more or less a data set actually. Okay, similar to data sets you see in SAS, in SPSS, and Excel. That is data frame. All right, so you can create data frame by using data.frame. Right, you can pass different kind of object inside. Okay, that you want to use. So example, I can create data frame here, called data frame, my data frame here. I can say name, Alice, Bob, Charles, that's character. We have age, we have a score. So this is the data frame that I can run this guy now to give me data frame called data_frame. So this one I can now say, okay, which class does it belong to? It's a class. Let me find the class data.frame. Okay, _frame rather, _frame. So it give me data frame, this class it belongs to. So I can see what is inside of this, what is inside. Okay, I can just select this guy and run this guy only. Just give me name, Alice, Bob, Charlie, age, score. This is my data frame now. This is like data set now. We are getting closer to data set gradually. Okay. So this is structural data set, for example, now, right? I can create another data frame called creating using patient, or I can call it patient data. Okay, now I created patient ID. I say, see, my vector one, this vector now, don't forget. This also a vector. Here, I combine many vectors together in data frame to form data frame. The same thing here, patient ID, C, 1, 2, 3, 4, their age, diabetes, type 1, type 2, type 3, type 1, type 2, type 1. So, status, poor, improved, excellent, poor. So, patient data, I now create data frame. I now add patient ID, age, diabetes, and status. So if I run this line of code, I can run one by one if I like. I can also run together like this, right? There's no error to run, so there's no error. So I can now look at what is in my patient data. This is my patient data. I can now look at what is inside. I can see patient ID, age, diabetes, status. So this is the data set for me now. So if I want to access data set, the elements of each data set now, what I need to do is just to use dollar sign. That's why dollar sign is not allowed. It's not advisable to be used with data set, because it will break the rules of keywords. All right. So I just need to click here and say patient data dollar. I use dollar. It show me the list of my variables I have there, my columns, patient ID, age, diabetes, and status. So anyone I want to access, I just select it. For example, if I want to see their age, I just press enter to give me the age. So this is how to access each of the elements of your data set. Okay, each of the columns or variable in your data set, you have to access them. The same thing applicable to this first one I created here, data frame. I can access the name by just data frame slash data.frame underscore frame slash. Can you give me the name, score, and the rest? So I just look at it. This give me the name that are there. So I can also say names. Remember, we said that the other time. Names, patient data. Okay, give me the list of what is there. You can see patient ID, age, diabetes. Maybe you have forgotten the name of your data set columns. You don't remember. Maybe there are many names there. You want to be scrolling and be scrolling, so you just need to say names. Give you the names of all the list of the columns you have there. You can see them very easily. All right, so that is how to create data set and how to access each of the elements in it. Okay, so you can specify elements of data frame. Patient, I want to see patient 1 column 2. Okay, you can see like the way we did for the matrix, column 1 to 2. So I just specify column 1 to 2 here. Okay, column this by column now, column 1 to 2. So give me patient ID, this first column, second column, right? So this if I want to see column 1 to 5, I can just specify here. All right, patient, I want to see by using this index method now. But I want to use by their names. I can just say, okay, I want to see patient C, diabetes, status. So I want to see these variables, which means by using their names, I can just run to give me diabetes status. All right, I want to see, which we have done before, patient by age only. Or you can just run this line of code. You can see by patient only, by age only. So I just want to, for one element. All right, but a combined element, you can use the index method, which is the one we use here, or you can use name by name method. You can supply the names of the variable here or columns here. So that is how we handle data structure in R. So in the next class, I will be talking more about more on functions and control structure in R. So this is what we are able to cover today, and this element introductory to R, introduction to R rather. So in the next class we'll do more. So I want to thank you for your patience and for listening. We'll see you in the next class. Thank you.